and various aspects. And finally, we'll discuss about various applications of artificial neural network, and we'll try to make use of MATLAB in terms of programming, as well as neural network toolbox available with the MATLAB. How effectively we can make use of this MATLAB neural network toolbox for solving various problems. So basically, neural network. So actually, it is a information processing paradigm, actually inspired by means of biological nervous system. So most probably, how our brain behaves to a particular circumstances. Say some object is going to hit our body, so automatically we could able to recognize which part of our body may get affected due to that object hit, right? So we could able to identify the location immediately within the matter of few microseconds, or within the matter of seconds we could able to sense the location where our body may get a kind of attack. So according to the intensity of attack, we may react. Sometimes, if it is going to be very, very less impact, we don't bother about that particular attack. If the intensity of attack is going to be very high, so automatically we will do some sort of reactions. So these reactions will play a major impact on making various decisions according to our human brain. So the same strategy will try to be mimicked in the case of artificial neural network. So what we will be doing is we will be adopting the same topology. So in case of biological neural network, how the location in which your body may get being hit by any external object, how it can be sensed by human brain is actually the entire biological system is going to be massively parallelly connected. So that is the reason why we could able to identify the exact location in which the pain, or the in the form of pain, we could able to identify. So the location, the associated nervous system will process the information to the brain, and the brain will send the corrective action to be performed for that particular experience we had due to that object hit, right? So this is what normally any biological neural nervous system will perform. The same thing, the same concept, how we are going to adapt, how we are going to adapt to the situation, adapt to the environmental conditions. So as a human being, from our childhood days we have been grown up day to day, and we have learned a lot of things. So at the infant stage we don't know anything, and our father, mother may teach a lot of things. So they say, for example, we don't know about at the age of maybe up to 1 year, we don't know whether by touching a fire will create any harmful to our hands or skin. But once that experience is gained, till the age of your life exists, you never touch any fire substance at all. So that is the impact that has been recorded in your brain. So that kind of learning has been evolved in our experience, in the form of experience. So some kind of experiences we may need assistance, and some kind of experiences we need not require any kind of assistance. We may learn by ourselves only. So this is the concept behind artificial neural network. So some kind of applications, there may be a requirement of teachers or targets may be given to you. So accordingly, you have to achieve the targets. But some scenario, the targets may not be known. So in that case, by means of self-learning, or by means of without any guidance, we will be developing a suitable model according to the availability of inputs. So that is what the thing we will be doing in the case of neural network. What we are, our brain behaves into the practical scenario. The same thing, artificial neural network also will perform. So let us see about basics of biological neuron. Later on, we will focus on to the artificial neuron. So our human brain basically may consist of 10 to the power 11 number of neurons, and each neuron, each and every nerve cell may have 10 power 4 interconnections. So based on this 10 power 4, approximately every neuron may have 10,000 connections, right? So every connection may have its equal weightage. But the problem is whenever you have been hit by any other object, what will happen is that weight being experienced by the particular nerve cell among these 10,000 nerve cells, one or two or collective number of nerve cells may have different forms of what do you say, strength. So that strength normally we used to say in a biological way, we call it as synaptic strength. So that synaptic strength variation will create some sort of bioelectric potential development. So that bioelectric potential development will transfer the information to the next nerve cell. So this process will be keep on going once it will be reaching the brain. So normally this entire process from the one particular organ to the brain, the information process may be happened within a matter of maximum of what do you say, several milliseconds only. It need not be more than a second. So within a matter of milliseconds, this entire computation has been done within this nervous system. So this is a thing that induces the creation of artificial neural network that which will be exactly mimicking your biological neuron behavior. So let us see what are the parts of the biological network. So biological network, here I have shown only a pair of nerve cells. So here how it has been connected with respect to each other. So let us consider one nerve cell. Let us consider the left hand side I am having one nerve cell, and in the right hand side also I am having another nerve cell. So the center portion of the nerve cell called cell body, nerve cell, each and every cell may have its own cell body. So that cell body is called soma. So according to biological terminology, it may be called soma. So soma, from soma you may have so many types of tree-like structures. So this is called dendritic trees, and this is the branches of this tree is called dendrites. Dendrites. So every dendrites may have at the end of the tip there will be just like a small tip. That tip end is called synapse. So through this synapse only it will have a connection with another nerve cell. So you can see here one synapse is there. With respect to this synapse, this nerve cell is connected with another nerve cell through another nerve cell's synapse. Remember, these two synapses will not be directly connected together. There will maybe a small nanometer gap may be maintained. So whenever this, just like imagine you are having a capacitor, just like a capacitor, whenever dielectric strength breakdown, at that time it may conduct, right? Capacitor will starts to conduct. The same thing will happen in this synaptic strength. So whenever there is a, say here some disturbance is experienced by this nerve cell, so this is the next nerve cells approaching towards brain. So how information is going to be processed here is, so this nerve cell will identify the location which is going to be the shortest path for the brain. So it will be identifying the breakdown of dielectric strength, so that this through this dendrite branch, it make a contact with the next nerve cells dendrites through this synaptic connection. So there may be a synaptic breakdown, synaptic strength breakdown, just like a dielectric strength breakdown, which normally occurs. So synaptic strength breakdown is going to be occurring here. So based on that, that information will be processed along with the stem-like structure called axon. So the axon is going to be the part which will be collectively receives the information from all the nerve cells, not only from single nerve cell. Maybe an organ in the sense so many nerve cells may be connected with one particular axon. So axon will transfer all the informations of various synapses, and it will be transferred to the next nerve cells. Likewise, another 10 power 4 nerve cells will be connected within this neuron, and based on this, it will be approaching towards your brain. So this is what the way the biological information system is going to be working. Same thing we will try to mimic in the artificial manner in the name of artificial neural network. Let us, before going to that, let us see how it will be configured in the artificial manner. So let us see, in the biological neural network, we have discussed various parts like soma, dendrite, axon, and synapse. So these are the various parts of your biological neuron. So same thing, these parts will be mimicked in case of artificial neural network. So soma is going to be represented as neuron. So the cell body is represented as neuron, and dendrites represents your inputs, whereas axon is carries your output, and synapse is the representation of weight, that is the strength of the nerve cell. That is normally in artificial neural network it represents weight. So let us compare the comparison between our human brain with respect to our biological neuron communication with respect to artificial neural network. So let us compare with several features. So let us see brain. Through brain, within a matter of nanoseconds, can be possible. Whereas with the help of advanced computational system, nowadays it has been evolved with various number of processes, like various number of cores can be possible, right? So we can able to perform parallel processing in a massive parallel processing can be possible. So that induces the information processing can be done within a matter of nanoseconds. And the size and complexity, I told, biological neuron seems to be highly complex the system. It is very hard to mimic the biological system exactly in the artificial neural network. Anyway, according to the design requirement, according to the applications, the designer can fix how many number of neurons may be considered and how many number of interconnections can be performed. So this is a way they can do it. And the storage capacity. Normally, storage, like our memory is the storage in terms of biological system. So there is no limitation at all. We can have, we have plenty of information that can be stored. So we don't know, infinite terabytes of information can be stored in our brain. There is no limits of kilobytes or megabytes or gigabytes. We can have infinite terabytes of information can be stored, but still it is assumed that only 20 to 25 percentage of brain we are using. But whereas in the case of neural networks, with the available memory storage devices, we can store a lot of informations and input output configurations separately. Tolerance, in the sense, it has the ability to tolerate the faults, and fault tolerant ability seems to be seems to be extremely good. So any kind of injuries we could try to evolve, and sometimes our nervous system will try to immune that particular injury, right? So that kind of self-immunization is not available in case of artificial neural network. So it gets disrupted when interconnections are disconnected, right? So any kind of disconnections among various interconnections, any one interconnection is going to be disconnected. It's highly difficult to retrieve the information. So that is what the problem associated with the fault tolerance ability. Whereas control mechanism seems to be complicated in terms of biological nervous system, because it involves potassium level, chlorine level, and ionization. So many uh, chemical chemical reactions may be required for controlling any action. Whereas in the case of artificial neural network, we are going to design it, so it seems to be somewhat simpler when compared with the biological nervous system. Artificial neural network seems to be simpler. In the simplest way, we can easily implement a control mechanism. So I already told the dendrites or the inputs to the artificial neural network. So you may have so many dendrites may be connected with a single neuron according to the previous biological neuron network diagram as shown. So previous diagram. So I have represented dendrites are nothing but your input signals. So each and every branch, that is dendrite, may have certain weights. So W1, W2 may have n number of W, and sometimes W1, W2 values may be same, sometimes it may be different. So that is not an issue, but it may have some weights. Each and every nervous system, or each and every neuron which is going to be connected with this single neuron may have its own weight. So it has been connected with the point called synapse, right? So that's why synapse is the point in which it makes a connection. So synapse represents your weights, and the soma is a representation of your neuron and outputs of this neuron. So the neuron, whether it has to fire or not, which means whether it has to process the information to the next nerve cell or not. So that is going to be based on the output signal. So axon will take care of the output, because from the one particular neuron there may be a possibility of 10 power 4 interconnections with the neighboring neurons. So which nerve cell has to be fired, whether all nerve cells associated with the neuron has to be fired or one particular nerve cell has to be fired. So that decision will be done by this neuron, right? So this is what a biological neuron normally works. So the concept of neural network actually has been evolved in the earlier stage of 20th century, but almost 1940s it has been developed. It is assumed that neural networks can be used to solve some logic gate problems like AND gate or OR gate, or NAND gate and NOR gate. So merely for solving logic gate problems, they have been evolved. So the most fundamental neural network model that has been suggested as McCulloch's neuron model. So actually, they have considered binary inputs only. The McCulloch's neuron model. So input may have either 0 or 1, and accordingly, your output also may be a 0 or 1. So in order to make output, there may be a threshold function instead of this place, the neuron. So this is your inputs, x1, x2, xn, and this is your synaptic connections, w1, w2 weights are nothing but your synapses, and your neuron will have to perform weighted sum of inputs. So w1 x1 plus w2 x2 plus, it's a weighted sum of inputs. So according to this input is concerned, it may have weight as W1, input value is X1. So you have to consider the product of weight. So weighted sum of inputs. So W1 X1 is one weight associated with the input. So this input has the strength of W1 X1. Second input is W2 X2. Likewise, you may have n number of neurons that may have W1 up to Wn Xn. So you may have to make a decision. I said already, McCulloch's neuron model, it's a binary input-output configuration. So it will fix a particular suitable threshold value. Sometimes, if say, let us see, we have to develop a AND logic network. So if according to AND logic, all inputs are seems to be 0, then your output seems to be 0. If any one output is again 1 or high, still the output is going to be 0. If all the inputs are going to be high, then only you may get the output is as going to be high. Otherwise, it seems to be always 0. So just like that, the threshold function is the important one, or normally we used to say it's an activation function associated with the weighted sum of input calculation. So what we will be doing is we will be performing the computation at this end only. So important part of the neural network is this area. How we are performing weighted sum of all inputs, right? And with respect to that weighted sum of inputs, we need to compare with the threshold value, and whether what type of output we have to give, whether we have to give output to all neurons connected with this single neuron, or we have to give only single output. But earlier stages of artificial neural network have only single output, but later on they have been developed with multiple outputs also. But there are some issues with McCulloch's model, because that model may not be useful for solving linear classification problems exactly, especially for XOR gate. it is very difficult to solve a linear separability. So linear separability is a kind of classifying zeros and ones by means of a single straight line. So McCulloch's model for XOR gate, it is very difficult to plot. It is very difficult to draw a single line that separates zeros and ones, because we all know XOR gate XOR gate logic outputs, right? So whenever both inputs are different, at that time you may get a high output. Otherwise, you may get always zero as the output, right? So the McCulloch's model seems to be failure for logic gates, especially called the feature linear separability, especially for XOR gate. But still, the McCulloch's model seems to be very simple in nature and computationally efficient for solving logic gate problem, except XOR gate. But the major drawback is it is highly failure in case of linear separability issues. And this is a generalized representation of artificial neural network. So inputs, weights, and neuron processing node. It's a function, normally weighted sum of inputs. How the output is going to output represents O here. So the output will be a function of weighted sum of input. So weighted sum Wixi, if you are having n number of neurons, you may have I is equal to 1 to n. So it's a function based on the threshold we are going to use. It will produce as the respective output. Then later on, with the help of single neuron, is it possible to learn a task? So that was the question has been raised. Previously, there is no one think about learning. Then later on, Rosenblatt introduced whether how to train learning, how to train the particular artificial neuron so that can be extended for some other applications instead of simply logic gates applications. So in that case, they have arrived a model called a perceptron model, a single neuron perceptron model. So actually, it's a simplest form of neural network, but the greatest thing is it may be having adjustable synaptic weights with a hard limiter as a threshold function. So this is what the representation of, let us say, a two-input perceptron model. You may have only two inputs, and you'll be combining a weighted sum of input. So the linear combiner represents a weighted sum of two inputs, that is W1x1 plus W2x2. So that summation output will be given to the hard limited block. So we will be already fixing the threshold. If the sum of input increases beyond a certain value, it produces output like that. Otherwise, the output will be low. So according to the threshold value we are going to be fixing, if threshold value is 0.5, the sum of output is greater than 0.5 or equal to 0.5, then output will be always higher. So this is the way initially the perceptron model has been evolved, and still it somewhat overcomes the issue, but again the problem arises with the linear separability issues, like how McCulloch's model seems to be somewhat simpler, but this perceptron model could be able to train the neural network as early as possible. The training is the feature that has been adopted with the single perceptron model. Now, the important parameter of neural network, artificial neural network, is called weights. So without a proper change in the weight, we cannot recognize whether that particular organ, according to our human body is concerned, whether any object has been externally hit. So we could not able to recognize unless otherwise our nervous system will coordinate the information to the brain. So automatically brain will do the corrective action in the form of pain, or it will advise to do some kind of corrective action to be performed. So the firing of neuron from one neuron to another neuron, the information has to be fired immediately, which means has to be communicated immediately. For that, for firing a neuron, you must have sufficient weight. So if you have increase in the weight, that is positive weight in the sense that always fires the respective uh, uh, fires the suitable signal to the nearest nerve cell. Thereby, that information will be communicated all along to the brain. Whereas if your weight is going to be negative, what will happen is it won't fire. So if suppose other part of the body seems to be comfortable in the sense, other nervous system will not need not be fired at all. So only the part of the body which may experiences any kind of disturbances externally, that alone need to be fired. So other nervous system will not make any kind of firing signal. So that's why it will be in the inhibit mode, and it won't create any kind of change in the weight. Instead, the weight will be in the negative direction, right? So this is the actual case. Now, in order to assess these things, we need a activation function. So the activation function is the one which requires, so in the perceptron, so here hard limiter is a kind of activation function. Likewise, there may be various types of activation functions can be followed in the artificial neural network. So some of the famous activation functions are linear function, uh, threshold function, sigmoidal function, tangent, and hyperbolic function. So threshold function we all know, with respect to one particular value, if it is greater than particular value, it will be on, otherwise it will be off. So let us say a step input in our control system. Normally a step input is the one, if it is greater than or equal to 0, if it is kept as 1. Otherwise, if it is less than 0, it will be always 0. So that is the way you can imagine the nature of threshold function. Likewise, piecewise linear will be having a constant slope. So these are the things that may be quite needed as far as a very good artificial neural network has to be properly trained. It should make use of proper activation function. So like piecewise linear or threshold activation function, or there are tangent, so many activation functions I have listed. So you have to use any one of the activation functions for its firing. And another representation of linear neuron is a term called bias. So bias is nothing but an additional input vector, weight vector actually, additional single weight value, which is normally required to perform the neural network in a better manner. So, like a straight line, we may have y is equal to mx plus c. So, y is equal to mx, we know, but plus c is a way, sometimes it need not be always going along with the origin. Sometimes a straight line may be passing through some other direction. So, that plus c will create whether c value is going to be 0, you can say it will be straight line will be passing through origin. If c value is non-zero value, so straight line may not be passing through the origin. So like just like your C, the bias will make an impact on the training or learning of neural network. So another activation function is called sigmoidal activation function, which basically makes use of an inverse exponential operation, and it's an exponential curve. So you can see it's an exponential curve, so a smooth exponential curve. Some kind of real world problems, the operations need not be a binary discrete states like low or high. Sometimes there may be a gradual variations in the output may also be required. So for that case, this kind of representation of activation function may be required. And there are some things that has been missed out that particular perceptron model. Still, that model that missing out non-binary input output, and that may be a non-linear summation block may be missed out. And even though we have used a sigmoidal activation function, But as far as perceptron model is concerned, it may make use of simply hard limiter activation function, that is simply a threshold activation function. But there is a hope, there is a scope for make use of sigmoidal activation function or hyperbolic activation function in the late 1980s and 1990s. It has been used with different forms of activation function. But earlier stage of perceptron model, there is no smooth thresholding. It's a hard limiter only have been used as an activation function. And temporal information sharing also has been missed out in the previous model. Now the basic models, how the ANN can be classified according to the various models of artificial neural network. So basically, artificial neural network, according to the type of interconnections and according to the learning rules we are going to use, and according to the activation function, we can create multiple number of artificial neural network architectures. So let us see one by one, based on interconnections, based on learning rules, and based on activation functions. So if it is an interconnections case, the interconnection can be done either in a feed forward case or feedback. Normally, it may be a recurrent nature, right? So feed forward or feedback. Even in the recurrent case, as well as feed forward case, either make use of single layer or multi-layer neural network architecture. Likewise, in the recurrent network also, you can have single layer and multi-layer architecture. So let us see one by one what is feed forward neural network. So in the difference with the perceptron model make use of single neuron, whereas later on it is observed that the single neuron may not be performed for solving practical real world problems. So some real world problems may takes care of more than two inputs or three inputs. Sometimes they need more than two outputs or three outputs. So accordingly, what we have configured the structure of neural network is, you may have basically a three-layered architecture called input layer and hidden layer and output layer. So input layer is the representation of all your equivalent to your biological neuron dendrites, and the hidden layer is going to be the layer which perform your weighted sum of inputs calculation as well as associated activation function. So each and every neuron in this layer may have its weighted sum calculation associated with activation function calculation. So that weighted summation as well as activation function combined representation will have produces one output. That output will be reflected back to the output units. So here it is massively interconnected. So all the hidden neurons representation will focus on all the outputs, right? So accordingly, which nature of output you are going to focus on, you can retrieve that particular output for the particular application. So this is the representation of feed forward. So there is no interaction between input and output units. So it's a forward way from input to the output. It's a unidirectional way. The information flow will be there. This is called the feed forward neural network. So some of the equations that has been given, but anyway, the architecture point of view is sufficient for as a beginner. It is sufficient in terms of architecture point of view. So in case of multi-layer feed forward, what will be the cases? Uh, Sometimes the real world seems to be highly complex in nature. So in the highly complex real world problems, sometimes the output may not be exactly required, which is we are looking for, right? So what we will be doing the performance enhancement. So we will be increasing number of hidden layers as one more layer. So instead of here one layer, we will be having one more hidden layer, and the number of hidden layers, maybe here I have only one set representation. Likewise, you can have another set of representation of hidden layer, and even if it is required, you can have another third set of representation of hidden layer. So as number of hidden layers are increasing, the what do you say, the accuracy in terms of the outputs we are looking for will be definitely improved, right? So this is the concept behind multi-layer feed-forward network. Especially, it is used to solve complicated problems, complicated, highly non-linear problems. We can make use of multi-layer feed-forward network. So the next category, so far feed-forward network we have discussed single layer as well as multi-layer feed-forward network. Whereas feedback in the sense, so you may have inputs. So this is the input, and this is your neuron hidden layer. So this is your output. So feed-forward, you may have input, weights, hidden layer, and output layer. Whereas feedback, the output layer with the proper some delay will be given to the once again to the respective input neuron, right? So this is called feedback network. So one particular neuron's output with some delay introduced will be given to the same input. So output of the neuron will be given back to the input. This is called feedback network, right? So feedback sometimes done in a lateral way also, which means lateral way in the sense it may be one particular neuron's output will be fed back to the particular neuron only. It may not be going for some will say this is output that has been retrieved from this neuron. So only one neuron will be interacted with the particular previous neuron, previous hidden layer neuron, right? So this is output. The output is fed back to the hidden layer because hidden layer is the thing that will perform the weighted sum calculation. So it will be acting as the feedback part will be acting as an input in addition with the inputs from the input layer. It will be added as additional input to this neuron to be performed in the hidden layer calculation. So recurrent networks is somewhat different, whereas previously in the feedback, you may have the output of one neuron will be given back to the same neuron, whereas recurrent network is not so. Output of the neuron may be highly interconnected with every neuron. So it need not be feedback to the same neuron. It may be feedback to every neuron. So first neuron, then output of this will be given to second neuron. Output of this will be given to third neuron. Likewise, all the outputs will be interconnected with all input neurons. This is the way recurrent networks will work. So why we need to study this recurrent networks? What is the ability of this recurrent networks in the sense it will be used to store the information. Because of this recurrent network only, we are having the memory in our human brain. So if there is no recurrent network action to be happened in this case, then we don't have any kind of memory space available in our brain. So every day may be a new activity, a new learning for us every day-to-day life. So somebody may hear that short-term loss or short-term memory loss, or so these kind of issues are associated with the problems associated with this recurrent neural network configuration in their biological neuron. So if their recurrent network configuration seems to be good, then they can easily recollect the information that is available, that is already stored in the brain. So the next category, so far we have discussed about interconnections, about ANN models. The next category is about learning. So learning in the sense, learning is an important thing of any kind of artificial neural network. So how learning can be done in the sense by means of two ways, either parameter way or structural way, we can perform the learning. So learning is a basic thing. Now sometimes learning may be also be known as training, right? So I already told from the childhood days onwards, we keep on learning. Some things we have been, it has been already recorded in your mind. Say touching a fire will definitely harm our hands or our skin. So this thing is already recorded. So we never touch any substances that catch fire. So this is the thing. This is called learning, right? some things maybe by our parents advice we may somebody else may able to know, oh it will by touching this it will harm our skin. Somebody may already experience this by, they may be, even though their parents are saying, without their knowledge they may able to try to touch the particular fire substance. So at that time they may experience the pain, right? So sometimes learning or training can be processed with the support of parents or teachers. Sometimes the learning without the support of teachers can be possible, right? So this is called with the teachers or with the parents the learning is performed is called supervised learning. And without supervisors or without teachers the learning is going to be performed is called unsupervised learning. So the third case is called reinforcement learning. So it is the case that carries with that carries with the availability of teachers or parents, but they won't be supportive all along the way. So they will be supportive only for the evaluation purpose. So it has to be a self-learning, just like an examination we are doing. So in the examination process, like in the semester pattern, we may conduct a lot of internal assessment tests, right? We may have monthly tests, or we may have so many tests to given to the students. So students may get evaluated for whatever be the mistakes they have done. They may be notified by the teachers. So this is coming under supervised learning. Whereas reinforcement learning is a kind of thing when they appear for end semester examination, they don't know what kind of mistakes they have committed in their answer sheets. It will be evaluated by the teachers and the grades will be shown to them. So there is no chance for any corrective actions. Maybe a revaluation procedure is there, but still there is no chance for the students do any corrections on it on their paper, on their answer sheets, right? So this is called reinforcement learning. It's a better, very good example of understanding the concept of reinforcement learning. So supervised learning, unsupervised learning, and reinforcement learning. So these are the things we are doing now. So let us see the architecture how supervised learning will be performed. So you may have input X and actual output Y. So the Y has to resemble the X value. That is what my target is. The Y and X must be same. So I have to evaluate the error, right? So if the error seems to be 0, then it means that y is equal to x. If the error is not equal to 0, automatically what we'll do is we'll adjust the weights, that is synaptic strength in the neural network. We'll adjust the weights, and once again we will evaluate the corresponding given input x. We'll be evaluating y values, and it will be keep on going, right? So this is the process we will be doing in the case of supervised learning, right? So let us see unsupervised learning. Unsupervised learning, it is used to classify the patterns within the particular cluster. So you may have various number of patterns may be collectively placed at one particular location. So those patterns may be grouped into various segments, and they may be categorized, right? So this may be called pattern classification, right? So among the grouped patterns, we'll be identifying different patterns and we'll be classifying those patterns, right? So this is called, this is one of the features of unsupervised learning. So conceptually speaking, there is no target at all. So there is no target may be given. There is no availability of teacher. So still by means of self-learning, we'll try to categorize those patterns and we'll try to do it. So this is called unsupervised learning, and pattern classification and pattern what do you say, recognition is one of the examples of unsupervised learning. So self-organizing is one of the famous unsupervised learning mechanism, and there is no kind of feedback so available in case of this self-organizing based unsupervised learning. Still, it has to discover various irregularities and patterns in the presence of unsupervised learning. And reinforcement learning, I already told. the teacher or parents may be available, which means you may be knowing the actual output, but the reinforcement signal, so, right? So previously you can see in the supervised learning, you can see the desired output is given. So desired output is given, that will be just like a teacher or parents. You may be already knowing what is the desired output. But here, the reinforcement signal, the desired output may not be always same. So they may be changing instantaneously. So you have to maintain 12 volt, you have to maintain 30 volt, or you have to maintain 20 degrees centigrade, you have to maintain 25 degrees centigrade. So according to the time level or according to the voltage level, it may be changing. So automatically the error value also has to change and it has to adapt the weights. So this is a case in case of reinforcement learning. And a very important thing, features of neural network is its memory. So auto association, hetero association is a very important thing in even in a normal human being. These are the very important things you have to always know. Say for example, a pattern is given to you. It is associated with which pattern? Whether it is a irregular. Say this is a pattern. So by looking at this, this side is incomplete. So based on this already stored information available in our brain, it may be a triangle, it may be a circle, or it may be a square. So it will try to look at this pattern, and based on this and the standard available shapes available already stored in the information in the memory, so it can able to recognize it's a square. So this is called auto association. So this feature is already recognized within our mind itself, within our brain itself, auto association. But most important feature is hetero association. So we will be listening a music, and sometimes we'll be moving into a dream. So we'll be placing ourselves in a hero position, and we'll be assume someone else as heroine, and we will be keep on listening the song. And sometimes we could able to recollect the movie name, movie director, movie music director, locations in which it has been shot. So everything we could able to recollect. So this is called the hetero association, right? So auto association and hetero association are the two important features of neural network. So this is what I want to say: auto association and hetero association. So auto association is associated with a particular thing, like it's a character A. Auto association simply recognize it's a character A. Whereas hetero association, Niagara means it's a kind of waterfalls. So that kind of information also is available in our information. So this is the main important features, and these are the various terms associated with terminologies associated with the ANN. So weights, bias, threshold. So already we discussed the weights. It's a synaptic strength. Bias is an additional weight. Bias is nothing but an additional weight in order to improvise the performance of ANN. So threshold is in the name of activation function we have used. So we will move on to learning rate and momentum factor. So yeah, learning rate. Actually, learning rate is used to adjust the weight. So by selection of proper learning rate in your artificial neural network architecture, we can change the respective values of weight, or we can able to adapt the respective values of weight in the artificial neural network structure, right? So normally the learning rate will be in between 0 to 1. So that is the standard value of learning rate. And momentum factor is another thing in order to improvise the training and in order to identify the testing and evaluation of samples. The momentum factor will be used to uh, improve the convergence of the system, artificial neural network. And another parameter called vigilance parameter, so it will be used to identify the similarity among the patterns or similarity among the data, and it will make into separate groups or clusters, right? So that will be the idea behind this vigilance operator. So let us see the different applications. Thereafter, we can move on to the MATLAB. So neural network, as I already mentioned earlier, for fault tolerant applications or image recognition application or image processing applications can be used even in for defense applications also. According to the hidden objects, we could able to identify whether that particular object belongs to our troop or enemy. So just like that, we could able to identify the by just looking at the image, we could able to identify the particular pattern, and we can able to recognize the character by means of association based memory. So associated pattern can be recollected. So pattern recognition and pattern classification applications, and function approximation, what type of nature of function it belongs to, whether it is belongs to a non-linear curve or it may be a linear curve, and prediction applications like market stock market predictions, and load growth in terms of power systems point of view, load demand growth predictions, and short-term load forecasting, long-term load forecasting. For prediction type applications also we can make use of it, and especially for control application like inverted pendulum problem, highly non-linear complex nature of problems also in online or in real time we can make use of neural network as an efficient tool to solve. And to conclude with the major strength, so it can be used to model any type of complex and nonlinear systems. We can able to design a neural network. There is no doubt about it. But still, it is not cannot able to what do you say? It's a kind of whatever be the mathematical concepts we are using in a traditional computing techniques, the same way neural network also will do. But only thing is the conventional mathematical tools can do the same work with a lot of computational time. But if you properly train the neural network with as many as number of inputs, the neural network will do the decision within a matter of fraction of seconds, or not even a fraction of seconds, fraction of microseconds can be possible. So let us move on to the MATLAB part. I can discuss a MATLAB based how neural network can be used in a MATLAB based environment. So let us see, my aim is to data classification. So let us consider logic gates or any kind of data classification applications we can use neural networks. So, so here you can see the major steps whenever you are going to implement a neural network. You are going to perform artificial neural network design. These are the 6 major steps you need to do. One is you have to collect the information, that is data, and then you have to create the network, you have to configure the network, you have to initialize the weights and biases, then train the network, validate the network, and use the network. MATLAB is the easiest platform. You can easily do the neural network design. So let us see, I'm going to design a perceptron neuron model for logic gates applications. So first of all, I'm going to, since in the MATLAB editor window seems to be font sizes or seems to be very less, I make use of this word representation. Later on, I can show you the files and respective outputs for pattern classification or data classification applications. So this is the MATLAB code I have used here. So I have used 20 samples, and I have created samples with different datas, right? So you may have X sample. I am using rand-n command in order to create a random normal distribution information of data. So you may have 2 comma n. So it's a rand-n is a random normal distribution value with the proper mean and variance value. Here I am using 20. So 20 sets of x value may be created, right? And for this question, likewise, you may have another set with rand n, 2n plus offset. I have some offset I have used, that offset value is 5. This is simply for data protection only. So I am not going for initially logic gate application. Instead of logic gate application, how data classification has been done with respect to this neural network. So this is what the thing. I am feeding my own data x and generating my own data and y, and those data are going to be plotted here, right? I am going to move on to the MATLAB window, and let us consider the same coding has been same coding has been done here. So n is equal to 20, offset 5. I have created x data and y data, right? So I am going to plot the curve. So you can run the program. So you can see, so program is yeah. So you can see the command window. The program has been started to execute. So this is the plot I have been represented. So I have marked various points, collective points, right? So what I have done is I have plotted the input and output vectors, target vectors, in the form of x and y. So now what I am going to do is I am going to develop a neural network model. So I already told I am going to consider a perceptron model. So perceptron, I am going to create and train a perceptron model. So net is the standard representation, or else you can make use of any word. But here perceptron is the inbuilt command available with the MATLAB. So net is equal to perceptron, you can say. So net is equal to, you have to train the network first. So train net of x comma y. X is the input, y is the output. So net I have already mentioned as perceptron, or else you can directly represent train perceptron comma x comma y. That is also can be done. So I have done this coding here. So I have already written. I am just trying to uncomment this lines so that so net and net t. So what will happen is once it has been done, what will happen is you can see a neural network window will be open. So you could see a neural network window has been opened, and so here you can see the number of inputs as 2, and it's a perceptron model with the bias b is being given, and input weighted sum of inputs have been given. So it's a hard limiter function. I already told it's a perceptron model. It's a hard limiter function we have been using. So for perceptron model, hard limiter function only is available, right? Then output. So you may be looking for single output, right? So it can able to identify various performance graphs. So performance in the sense, ultimately we are looking for least error. So error should be as minimum as possible. So at the beginning of the training, he get able to 10 power minus 3. The error is that is point not 1. But at the end of the training, you can see it's up almost 10 power minus 9, which means almost the error is 0. So very negligible error, and it has been successfully trained now. Now what I have to do is now for this trained information, I have to classify pattern classification. So there is a standard command available called plot PC, right? So, so plot PC is a pattern classification command. So if you run this code once again, you can see a line that classifies both samples separately. So this is one set of sample, this is another set of sample. So this is the way pattern classifications will be performed with respect to perceptron neuron model. Now I could give you an example. If suppose any logic gates are being used, how with the help of neural network, how to make use of this logic gates. So let us see. I'm going to comment all those things which has been discussed previously. So you all know about AND logic. According to AND logic, the logic gate is I'm using two input AND logic. So two input, one output. So 0 0 output is 0. 0 0 1 output again 0. 1 0 again output is 0. 1 1 output is 1. Right. So I'm going to design the same perceptron model in terms of program, and the same thing, plot PV, net, perceptron. I'm going to give the same things in terms of initial weights as well as bias weights. I'm going to define, right? So after running, you can see the ones and zeros have been classified here. So this is another example how pattern classification can be done for logic gate example. Now another thing is in MATLAB there is an inbuilt neural network toolbox is available. Instead of coding, you can do NN. You can go to straight away type NN start in MATLAB window. You can find a fitting app, pattern recognition app, clustering app, time series app. So you can go for pattern recognition app. You can go to pattern recognition. You can click next. So already some example data sets are available. So sample classes, iris flare, breast cancer, types of glass, thyroid. These are the standard data sets available in the MATLAB. I'm using MATLAB version 2014. So maybe in the advanced version, there is another advanced ANN concept called deep learning toolbox. That is the extended in-depth knowledge of ANN may be required. So in terms of RELU function will be there in terms of deep learning. So there is another era of ANN, extended era of ANN. So nowadays it is quite common by means of scientific researchers to focus on deep learning concept. So here there are totally 699 samples are there. I think among this 699 samples, 10 percentage of the samples you can change this thing, training, right? But it is always advisable you have to train at least among number of samples, you have to train at least 70 percentage of the samples. By default it will be given at 70 percentage, but you can change validation 10 percentage, testing 10 percentage, you can change, right? Thereby you can fix and number of hidden neurons. By default some 10 neurons may be available, you can change it to 20 or 30, no issue. And number of output. So this is coming under multi-layer architecture. So previously hidden layer, we have used only one hidden layer. It's a perceptron model. So perceptron model make use of only one neuron. So that is not an issue. But here the problem is a multi-layer architecture. So I'm using as many as number of hidden layers. So here 20 means just like this, there may be 20 number of hidden layers may be used. So the entire output will be given to this output layer, right? So that is the architecture of multi-layer neural network. And by clicking next, you can have the option. So among 699 samples, I have chosen 80 percentage, so approximately 559 samples. and 10% is given for validation and testing. So you can train, you just click train, and you can once again click train. And if you want to adjust the network size, that can also be possible in the middle of the time. Instead of 20, if you want to change it to say 15, that can also be possible. Not a issue, right? Again, you can try. So the region of convergence, you can see how far the class of data, how each data has been configured with respect to false as well as true positive rate. With respect to, this is the training sample of 599. This is validation and testing. This is the overall entire data sampling, how neural network has been trained with respect to input and output layer. So being a feed-forward architecture, you can see the cloud confusion matrix is a kind of thing. If you add all the